Section 8.3, Infinite Series. This section will look at the definition of the infinite series, partial sums, geometric series, and telescoping series. For infinite series and the sequence of partial sum, given a set of numbers, the set of A1, A2, A3, and so forth, or the sequence AN. To define the partial sum, S1 as a sum of the first term, or A1, S2 as a sum of the first two terms, or A1 plus A2, S3 is a sum of the first three terms, or A1 plus A2 plus A3, and so forth. So Sn as a sum of the first n term is A1 plus A2 plus A3, and so forth, up until An. We can rewrite this as the summation of the AK, k from 1 to n. The same way as S3 is in the form of the sigma notation or the summation of AK, k from 1 to 3. And all of these, they are called finite sum because they are the sum of the finite terms of the AK. From Sn is the summation of the first k term, the first n term, k from 1 to n. So as n approaches infinity, we can see this as the summation k equals 1 to infinity of the AK. And this one is called the infinite series. So from the n partial sums, and we write it as a sequence or the sequence Sn, which is the sequence S1, S2, S3, and so forth. From the property of the sequence in the previous section, if we can find the limit of the an as n approaches infinity and it approaches L, so we can say that the sequence an converges to the value L. So we apply the same property to this sequence of the partial sum. So as we take the limit of n approaches infinity of the Sn term, and it equals L or the real number L. Therefore, the sequence of the Sn or the infinite series, which is in the form of the sigma notation or summation AK, k from 1 to infinity, approaches L or equals L as well. And we can use this as the limit as n approaches infinity of the summation AK, k from 1 to n equals L. And this one we call the infinite series converges to the value L. In summary, we say that the Sn is the summation of the AK, k from 1 to n. And this one is called finite series or the finite sum. For the infinite series, the sigma notation AK, k from 1 to infinity. If the infinite series converges to the value L, that means the limit of the Sn, n approaches infinity, or the limit n approaches infinity of the summation AK, k from 1 to n equals L. So we are going to use the limit of the n partial sum to find the value of the infinite series as it converges to that number.